Okay, today I want to talk about section 11.5, the alternating series test. This is an outline. I want to talk about definition of an alternating series. The second one, how can you check whether an alternating series converges or diverges? Third one, I want to give error estimation. This is the definition of alternating series and give some examples. What's like alternating series? The is a series whose terms are alternately positive and negative. Here are two examples. Here, we have the sign changes alternately. Positive 1, negative 1/2, positive 1/3, negative 1/4, positive 1/5, negative 1/6. So what happens? The first one is like positive. Second one is negative. The third one is positive. So what does it mean? This is summation from n equals 1 to infinity. The minus 1 to what's the power? Power is the n minus 1. You can plug 1 into here. Minus 1 to 1 minus 1 is positive 1. You plug 2 into n, the negative 1. Plug 3 minus 1 is positive. Exactly. The positive first, next to negative, and positive. So one more. This one is the same to 1 of 1. The denominator is exactly same to the index. This denominator 1 is same to index 1. The 2 is same to index 2. The 3 is same to index 3. So numerator doesn't change. Bottom one is like index n. So that's it. This is exactly the one alternating series form. So like this. The next example, or this one, the either one is fine. You can use minus 1 to n minus 1 or n plus 1. Either one is fine. Either one is fine. We have the same answer. So here, what happens? The first one is negative. Second one is positive. Third one is negative. And so on. So what's that? This is summation. N equals 1 to infinity. So what happens? So we can change it. The negative, positive, negative, positive. So we can use minus 1 to power n. You plug 1 into n. The negative 1 to 1 is negative. You plug 2 into n. The negative 1 squared is positive. Plug 3 minus 1 cube is negative. Exactly this one. One more. Was it like a numerator? Numerator is 1, 2, 3. Same to what? Index. Same to index. So numerator is n. Was it like a denominator? The denominator 2 is the 1 plus 1, is right? It's like the 1 plus 1. The 3 is 2 plus 1. The 4 is 3 plus 1. Exactly 1 more than numerator. The bottom one is 1 more than numerator. So we have it. So this is polarity, like this. So an alternating series is of the form, so two things. Summation from n equal to 1 to infinity, minus 1 to power n minus 1 times bn, or summation n equal to 1 to infinity, minus 1 to n times bn. So it's right. So this case is minus 1 to n minus 1. The 1 of n is like bn. So here, minus 1 to n, and plus n over n plus 1 is like bn. We have the two forms. What is like alternate series? Minus 1 to n minus 1, always starting from the positive. You can do minus 1 to power n, starting with negative number. So we have two possibilities. So which one is the first? Positive first or negative first? We have the two alternating series forms like this. So Bn is always a positive number. The alternate series is convergent or divergent. How can you check? We can use alternating series testing. Here, if the alternating series summation from n equal to 1 to infinity minus 1 to n minus 1 Bn, like B1 plus, B2 plus, B3 minus B4 plus B5 minus B6 and so on. The Pn is just positive. That satisfies two conditions. The first condition, Bn plus 1 is less than or equal to Bn for all n. What does it mean? You plug 1, 2, 3, what happens? This is B1. Is greater than or equal to B2. B2 is greater than or equal to B3. B4, and so on. The number is smaller, 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 like decreasing. The Pn is decreasing. Second condition is the limit of Bn. The limit of Bn as n approaches infinity equal to 0. The satisfies these two conditions, we have this conclusion. Then the series is convergent. The convergent. How can you prove? So like this, we can use this one. What like Sn, we can think about partial sum Sn. Partial sum Sn. Summation from I equal to 1 to n, minus 1 to I minus 1, the Bi is right. Because you can change it. This is same to what? You can change limit. N is going to positive infinity. Summation, the I equal to 1 to n, minus 1 to I minus 1 Pi. So this is like Sn. This is Sn, is right? You can change the partial sums. So like this, expanded form. You plug 1 into I, 2 into I, 3 into I, and so on. The last one is like n. We have the B1 minus B2 plus B3 minus B4 plus B5 minus B6 and so on. So what's that? So we have this kind of things. What's it like S1? S1 is only add one term here, P1. What's it like S2? P1 minus P2. What's S3? S3 is like P1 minus B2 plus B3. What's S4? S4 is P1 minus B2 plus B3 minus B4. So we have these four numbers. I want to plot. How can you plot this one? Like this. Here we can use real line here. It's like a 0. The P1 is just a positive number. Here, P1 is here, the P1. So from here, we are going to the right-hand side, going to this amount. This is like a P1. So P1 is the same to S1. This is S1. What's it like a P2? P1 minus B2. What's it like a P2? We can use this result. What's that? The P2 is less than or equal to P1, smaller one. So what's like a negative sign going backward? Like a P1 is here, going backward. Going backward. This length is B2. P1 minus B2 is this point. We call S2. Here. What's like S3? B1 minus B2 plus B3. What happens to B3? You can use decreasing result. The B3 is less than or equal to B2 again from here. The B1 minus B2 is here. Only add B3. Add B3 going to right hand side. So like this. The smaller one, we have S3. The next is S4. The P1 minus B2 plus B3 is here. And subtract B4. Subtract B4. We can use decreasing result again. The P4 is the less than or equal to P3. Smaller one. Going to negative sign. We have this one. This length is smaller than B3. The smaller than B3. So this length is P4. So we have S4. You can keep going this procedure. This is S5. This is S6. This is S7, S8, and so on. like this, right? So what happens? So from here, we know the even part S2n approaches some number here approaches to S. S2n is going to S. What happens? S1, S3, S5, S7. This is going to another number. S is here, same number. So S2n minus 1 approaches, same number S. What happens alternating? Anyway, the even part is going to S. The other part is going to S. So what happens? Limit. N approach infinity. The general one Sn is going to S. So what does it mean? Conversion. So limit of Sn is, what is like limit of Sn? The limit of Sn is exactly summation n equal to 1 to infinity. So infinity a, sorry, this is like not this one. The limit of Sn as n approaches infinity is exactly same to summation from n equal to 1 to infinity. The minus 1 to n minus 1 Pn is going to S. That's it. This of S is finite number. So series is convergent. So that's it. This is the whole idea of proving this kind of things. Here's right. Yes, series is convergent. So detail is here. You think about it. This is like more details. So I just only give an outline of proof. So you can use my method, only the outline. The details here, the details like this. The details, you can read the details, exactly my outline, the same. So the test series, summation from n equal to 1 to infinity, minus 1 to n minus 1, 1 over n for convergence or divergence. I want to use alternating series test. What's that? We have two conditions. The sequence Bn is decreasing. The limit of Bn equal to 0. What happens? Alternating series is always convergent. We call alternating series test. So in this case, what is Bn? Here, what is Bn? The Bn is like positive part 1 over n. It's like Bn. You think about, was it like B1, B2, B3, B4? So we can plug 1, 1 over 1, plug 2, 1 over 2, 1 over 3, 1 over 4, and so on. What's that? Number is smaller, 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 like this. Smaller, smaller, smaller. So what's that? Decreasing. The first condition, that satisfies. What happens to the second condition? You can calculate limit. N approaches positive infinity, the Pn. So we have limit. N approaches positive infinity, 1 over n. What happens? N is going to infinity, 1 over infinity is 0. 0. So what's that? The series that satisfies two conditions. The first condition, decreasing. Second condition, limit is going to 0. The second condition, we have this conclusion. So we have this conclusion. Summation n equal 1 to infinity, minus 1 to power n minus 1 over n is convergent. By using alternating series test, right? So that's it. This is the whole idea for solving this problem. So like this. The next one. What's like the limit of Bn? The Bn is this one is Bn. We think about it like this. What happens? You can use relative rate of growth. You have to ignore 1, just n over n. N is crossed out, just 1. So we have it. The 1 is not equal to 0. What does it mean? So we cannot use alternating series test. When do you use alternating series test? Here. just limit of Bn equal to 0, but here non-zero. So we cannot use alternating series test. How can we solve? The limit of positive 1 is going to non-zero number. So what kind of a test do we use? We use the test for divergence here. Use a test for divergence. Would you like a test for divergence? This is a test for divergence. The if limit of an is not equal to 0 or does not exist, then series is always divergent. So it's always divergent. We call test for divergence. What happens? What's the limit of an? The next one. Here, n over n plus 1 is going to 1. What happens in minus 1 to n? You plug 1, minus 1 times 1 is negative 1. You plug 2, minus 1 times 1 is minus 1 squared times 1 is 1. Plug 3, negative 1. Plug 4, 1. What's that? 1, negative 1, 1, negative 1. What's that? Oscillating infinity many times between 1 and minus 1, like this. So limit does not exist. What's the answer? The limit of an does not exist. Series is divergent by using test for divergence. So here, by using the test for divergence, series is divergent. Okay, that's it. I'm gonna summarize these kind of alternating series problem. The alternating series is given. Was it like a good idea for checking conversion or diversion? Usually, we have to use two kinds of tests. The first one, the test for divergence. The second one, the alternating series test. So when do you use test for divergence? Here, the limit of Vn is not equal to 0. You can use test for divergence. So when do you use alternating series test? So here, the limit of Bn equal to 0, what happens? You can check. The sequence is decreasing or not. Sequence is decreasing, yes. Series is convergent by using alternating series test. Was it like a key part for using the test for divergence or alternating series test for an alternating series? The limit of Bn. The limit of Bn is not equal to 0. You have to use test for that divergence. The series is always divergent. So limit of Bn equal to 0, you can check. The sequence Bn is decreasing or not. Sequence Bn is decreasing, you have to use alternating series test. Series is convergent. This is like a whole idea. I'm going to summarize. Here, summary for an alternating series. Given an alternating series, summation from n equal to 1 to infinity, minus 1 to power n minus 1 times Bn. Summation from n equal to 1 to infinity, minus 1 to n times Bn. We have either one, the alternating series, where the Bn is a positive number. The estimate limit of Bn. It's like a first step. Case 1, the limit of Bn is not equal to 0. What's the idea? This series is always oscillating infinity many times, so limit always does not exist. So we can use the test for divergence. Answer is divergent. Answer is divergent. Second case, the limit of Bn equal to 0. In this case, don't use test for divergence. So we can use the alternating series test. You need to check the sequence Bn is decreasing or not. The sequence Bn is decreasing. We have this conclusion. Series is convergent by using alternating series test. This is like a whole idea. Check what? The limit of Bn is not equal to 0 or equal to 0. It's like the first step for checking the alternating series is convergent or divergent. Here, so what's that? You can calculate this alternating series. The limit of Bn, what's like the limit of Bn? Limit n is going to infinity, the ln of n over n. The which one is growing faster? The ln of n, the n. The n is growing faster than ln of n. The bottom one is growing faster than top one by using relative rates of growth. So answer is 0. Yes, satisfies this condition. You can check decreasing or not. This is very clear. The which one is growing faster? Bottom one is growing faster than top one function. What does it mean? The ln of n over n is always decreasing. This is always true, but I want to use another method for checking the p ln of n over n is decreasing or not. I can take the derivative here. You can use quotient rule. The ln of n prime times n minus ln of times n prime. ln of n prime is just 1 over n. So we have 1 over n crossed out, just 1. The ln of 1 n prime is just 1 minus ln of n over n squared. So what happens? So n is greater than or equal to 3. Was it like a graph of ln of n? The ln of n is like this. ln of n. So this is e. We have ln of e is just 1. Was e is 2.718. It's right, like this. You can choose 3. What's that? Find ln of 3 is greater than 1. ln of 3 is greater than 1. What's that? 1 minus ln of 3 is less than 0. We can plug 4. The 1 minus ln of 4 is also less than 0. So this is always less than 0. What happens? The derivative is always less than 0. What does it mean? The sequence Pn is decreasing. It's right, decreasing. It's true. So like this. So Pn is decreasing for n is greater than or equal to 3. So we can use alternating series test. The Pn is decreasing. The limit of Bn equal to 0. We have this conclusion. Summation from 3 to infinity minus 1 to power n plus 1 ln of n over n is convergent. The convergent. This is always true. So it's good. It's the whole idea for checking convergent or divergent from alternating series. The next one, estimating sums. Summation from n equal to 1 to infinity an converges. So what does it mean? We have convergent number S. You can change this one to limit and partial sum, like limit of Sn. This is like Sn, limit of partial sum. So what happens? N is going to infinity, Sn is going to S. This is like exact meaning. This is exact meaning. This is exact meaning. S minus Sn, you subtract the S from both sides. S minus Sn, sorry, Sn. Right, the next one. The Sn minus S is approaches 0. So we have Sn minus S is going to 0. Only replace the S minus N, we have the same answer, always going to 0. It doesn't matter. Only the direction, The positive direction is going to 0. The negative direction is going to 0, always going to 0. So we have this one. So we have a name. The S minus Sn is remainder or error. The remainder or error. So alternate series estimation theorem. The S is summation from n equal to 1 to infinity minus 1 to n minus 1 Pn is the sum of an alternating series that satisfies the first condition, sequence is decreasing. Second condition, limit of Bn equal to 0. What does it mean? Exactly, alternating series test. The series is convergent, the convergent. So was it like a remainder? The remainder is S minus Sn. The S is exact number of this series. Sn is like some the like approximate values, right? What does it mean? The S is exact number, just Sn is approach S. The Sn is very close to S, just approximate value of S. Was it like error? Is right? Exact value minus approximate value is like error. The error is always less than y equal b sub 10 n plus 1. B sub 10 plus 1. So how can you prove this one? You can use the previous result. So this one is right. So this is S1, S2, S3, S4, S5, and so on, like this. So what happens? Here, you can choose two kind of things. And is odd or like even. So what happens? One example is Sn is here. This is Sn. What's that? The opposite one is Sn plus 1. You can compare. So S minus Sn, take absolute value. What's that? Only this length. Only this length. You can compare Sn plus 1 minus Sn. What's Sn plus 1 minus Sn? That this length is from here to here. This length is always greater. So like this. What is Sn plus 1 minus Sn? Exactly here. What is S3 minus S4 minus S3? What's that? S4 minus S3 is the same to what? S5, sorry, it's S5. S4 minus S5 is B5. Length is B5, right? What is like S4 minus S3? S4 minus S3 is, this is S4, this is S3. The length is B4. B4 is right. So what's like Sn plus 1 minus Sn exactly B sub 2 sub index. Index is same to bigger number. So we have exactly Pn plus 1 like this. But that's it. So we have error estimation. S minus Sn is what? Always less than y equal to Pn plus 1. This is already true. This is already true, right? It's like error estimation. So like exact proof is here. So this is only my explanation, same to my explanation. So here, show that the series is a conversion. How many terms of the series do we need to add in order to find the sum to the indicated accuracy? This one. So first one, I'm gonna show series is conversion. How can do that? So we can change this one to the summation n equal 1 to infinity minus 1 to power n minus 1 times 1 over n cubed. You can choose Bn first. What's it like Bn? Bn is positive part 1 over n cubed. So you can take limit first. What's it like limit of Bn? The limit n approach infinity, the Bn. This is limit n approaches infinity 1 over n cubed. 1 over infinity is 0. The second condition that satisfies from the alternating series test. What's the first condition? You can check. Sequence Bn is decreasing or not. You can plug 1 into n, 1 over 1 cube. Plug 2, 1 over 2 cube. 1 over 3 cube, 1 over 4 cube, and so on. What's that? Number is always smaller, smaller, smaller. What's that? Decreasing. So what's the conclusion? The series n equal to 1 to infinity minus 1 to n minus 1 times 1 over n cube is conversion. Conversion by using here the second condition and the first condition. Limit is going to 0, sequence is decreasing. We call alternating series testing. So we have this result. It's good, it's right. I proved this one. The second part, how many terms of the series do we need to add in order to find the sum to the indicated accuracy? This one is right, this accuracy. So like this. Here. So how can you check the error estimation? So what's like the error? This error is exactly the exact sum minus Sn. This is like error. This is like less than or equal this one. So we can use alternating series estimation theorem. What's that? The Rn. This is error. This Rn is exactly error. This error is less than or equal Pn plus 1. So we can use this one. So Rn is less than or equal to Pn plus 1 is less than 0.00005, 0, and 1 like this. So same to what? This is same to 10 to the, how many? 1, 2, 3, 4, 5, 6. The negative 6, we have 1 over 10 to the 6. So we have this result. Pn plus 1. Pn plus 1 is less than, so less than 1 over 10 to the 6. Was it like a Pn plus 1? The Pn is only positive part 1 over n cubed. You can plug n plus 1 into n. So we have 1 over n plus 1 cubed. The less than 1 over 10 to the 6. You have to flip. So we can think of the reciprocal of each terms. So 1 over n plus 1 cubed, you have to flip. So we have, this one is like n plus 1 cubed. 1 over 10 to the 6, only flip 10 to the 6. Only the reciprocal, what happens? Inequality, change it. So like this. Next, take power 1/3 from here. So n plus 1 cube, 10 to the 6. You can take power 1/3. You can take power 1/3, power 1/3. What happens? 3 is crossed out, only n plus 1. The greater than 3 is cancelled, only 2, 10 squared. Subtract 1 from both sides, was like n. N is greater than 99. So 100 minus 1 is 99. That's right. So we have this result like this. What is the final answer? So we need to add n list to the first 100 terms because n is greater than 99. N list 100 terms. This is the answer. I want to change this problem. The error is like this. We have equal sign. How can you solve? So we have equal sign. The equal sign is here. Equal sign is here. Equal sign is here. We have equal sign. The equal sign. The equal sign, equal sign, equal sign. What is the answer? So we need to add at least the first 99 terms, depending on. So we have equal sign or not. So we have two different kinds of answers for solving this kind of problems. Okay, so this is all for alternating series estimate theorem and the alternating series test. So this is all of today's lecture. Thank you for watching my lecture video. So if you have any question, any trouble, you can only write your question on the discussion board or send the email to me. So I and the Kasha and I will help you. Okay, thank you.